name is Marcello Pellicciari. I'm the scientific supervisor of the COMET project. COMET addresses robot machining, actually basically just milling with industrial state-of-the-art robots instead of machine tools. With, of course, we are addressing important challenges, not only because machine tools are up to 50 times stiffer than robots, but mainly because robots are designed or born especially for position repeatability instead of motion accuracy. So this involves a lot of big challenge. We are an industry-driven, exploitation-oriented project. At the same time, we did not involve any industrial robot manufacturer, just because we want to address all state-of-the-art robots to have the wider application visibility. What we did actually is developing a real platform with 4 basic configurations addressing different business models, different level of performances, and different way of cost of investment. From assessing the state of the art, we have 8 industrial demonstration cells addressing 4 different industrial sectors: automotive, aeronautics, high precision parts, and more. That we decided that were the most promising. We addressed and we started for 5 1mm actual accuracy on the workpiece, and towards different approach, basically 2 kind of different approach. One is based on predictive offline compensation, I will talk about this slide later. The other is on active online compensation. We just achieved the performance we actually aimed at. This important result also not only in terms of feasibility of new business model, but also, of course, of higher energy efficiency, much higher than the 30% actually addressed, cost effectiveness, so overall sustainability. The first approach actually is based on offline compensation. We actually are using state-of-the-art robots without no intervention, so potentially we are addressing the whole robotic machining cell available. What we do is modeling the main errors of accuracy, so motion accuracy sources in the robot, basically backlash, compliance, difference, and at the same time identify when they occur through simulation and through a software environment. We first of all identify when they occur and trying to avoid it with proper machining strategies, or we predictively address and calculate the errors to compensate it in advance. So we just create an adaptive approach able just to avoid, to compensate predictively the motion accuracy. With this approach, really cost effective, we demonstrated to be able to achieve much higher result than honestly we expected. The final result that is just proof to be able to have a solution able just to achieve accuracy of the same order of minimum accuracy machine tool, opening a new field. Actually, we are using external sensor somehow integrated with the closed control robot controllers. So basically, we are using one side an innovative tracker which is able just to monitor and to give a much more accurate feedback on the real position of the robot tool towards the workpiece, and then adding a real-time compensation. We had a special agreement with ABB for this course. When I talk about the robot manufacturing, in this cell we are using ABB, KUKA, but also RISE, Motoman, and COMET robots. So we have a wide experience, and also it was interesting just to assess the different performance. At the same time, with this tracker, you can achieve even higher accuracy with a piezo-actuated active compensation system developed by IPA. And so we achieve actually a accuracy of the order of cents of millimeters. Dissemination exploitation. First of all, our Jedi, Willem, was very good to involve all the partners of the consortium. And actually, we must say that dissemination was a success story, especially because it was the key of the success of the project. Not only because on one side we felt that it's a strong commitment versus towards the European Commission, since we were funded to with public money just to advertise and to communicate what we did with the public money, but actually also our partners, since are very involved about exploitation, really forced us just to communicate more. And actually we saw that these results were really profitable because we have now a strong interest on robot machining by many potential future customers. Moreover, I think that the dissemination approach was not only very effective also with the social media towards communication outwards, but mainly it helped us a lot to create a real team, communicating better from different work packages, and internal communication helped us a lot to have a really proactive, synergistic, and collaborative approach. This helped us a lot. I try to be as much as possible. Thank you.